Hi, everybody. Good evening. My name is Mims Wright. I'm going to be talking to you guys a little bit about maybe not how to go home right now and make a game, but definitely some of the different concepts behind what a lot of video games have in common. So things like how do we draw graphics on the screen? How do you do just an update loop, simple game mechanic stuff. So basically, this is going to be a series of talking through different concepts in game development and then showing a quick example with some code of how each one works. So a little bit about me. I am a principal web developer at Huge, which is a digital agency in LA. I've been a programmer for at least 12 years, depending on what that even means, and whatever that meant 12 years ago. And I've made a few games. I'd love to make some more. And those are some links where you can find more about me. So let's just jump right in there. First of all, this is all stuff that I basically sat down in an afternoon and said, I'm going to see what I can make as far as a video game in JavaScript, just to see what the state is of the modern browsers and everything. So a lot of the stuff you're going to see is not going to be top of the line stuff. Obviously Joe's work on the audio API with the audio API is way more sophisticated, and you should probably be using some more sophisticated tools, like some kind of something like 3JS for doing 3D graphics, or some game engine that already exists out there. You have a lot easier time. But this is more to teach you about the concepts behind what all those libraries are actually doing. So the first thing is the game loop. So really, every game has this sort of looping process that just takes every frame of the game. It's going to do some kind of manipulation to some data. So that might mean moving a character somewhere, or detecting a collision between two objects, something like that. Then it's going to draw the results of that calculation to the screen, and then just wait for the next loop to come through. So in JavaScript, we're using this example just uses set interval for that with a fixed frame rate, and runs this code every frame, or every time the set interval is called. So let's just jump right into a little demo. Actually, I'm going to show you the code first, and then let's get rid of this. OK. So here's my little game. All this is happening inside of a canvas element. We're using the 2D drawing context for all of this. So right now I have my interval set to 30, which basically is going to give me 30 frames per second. Well, roughly. It's not this isn't the number of frames per second. This is actually 30 milliseconds, but it works out to be about 30 frames per second. I have a little object called avatar, which we're going to be using. That's going to be your hero character on the screen. Right now, the avatar class really is nothing but a set of position variables, a size, and a color. So we're actually going to use that to draw a little box on the screen. Here's the set interval function I was talking about. And these guys right here are what's really doing all the heavy lifting in this game. So the update loop does everything it takes to update game state, and the draws everything to the canvas. So right now, nothing's happening in update, and draw is simply going to basically draw a rectangle and fill it with a color wherever the avatar is. So let's look at it real quick. All right, so in this game, nothing is happening right now. It actually is drawing this every frame. This is drawing a purple square on a gray square 30 frames per second. But nothing's happening because nothing's moving. You don't see anything going on. So we'll get to more of that next. OK, so next thing we're going to do is add some keyboard control. So most of you are probably used to working with this sort of push method of doing keyboard control, where you press a key, and that actually sends an event to JavaScript, and you would call a function based on the key being pressed. What we're actually going to be doing for games is more of a push method, or pull method, and this is also called polling. So because we have this update loop running every frame, instead of responding to the keyboard right away. We're actually going to be building kind of a list of keys that are already pressed during that time. Some programming languages allow you to do this more natively, but for us, we actually have to do some mechanism to record the keystroke into an array of keys that are pressed, and then pop it off again when you let go of the key. And because I looked around and actually this is what happens in your operating system and in your browser when you're working with keys. This is the same method is happening on the back end. Every frame, it's like pulling what keys are pressed and then initializing events out to your JavaScript code. So it's kind of like we're reinventing the wheel with this a little bit. But I looked around and I couldn't find anything that was doing this out there, so I actually wrote an extension to this library, keymaster. So if you're interested in trying this out at home, you can go here and check this guy out. So in our code, so I've defined just some constants to represent the different keys for the arrow buttons. And right here in my update loop, I've actually added some code. So it's just checking key is pressed right, key is pressed left. And if it is, it's moving your avatar's position by just a set amount of a set position. So like the V is really just like a change that's going to happen every frame when you have the key down. And the nice thing about this is you can actually have multiple keys down. You can have down and right pressed at the same time, and it'll move down to the right because it's going to trigger both of those things instead of having to run a separate keyboard handler for each of those. So I'm using my keyboard, moving this around, and that looks like it's working great. Moving on. So next, I want to take our avatar and actually make it look like something because purple square is not very exciting anymore. So I'm going to use the draw image command in the 2D context. So this is basically like, I show a sort of silkscreen printing model here because it's a pretty good example of kind of how it works behind the scenes. You're taking the data from an image and kind of printing it onto the canvas. So you can take the same data and print it as many times as you want. And similarly to like if you had a silkscreen press, you actually have to turn like your shirt or your paper if you wanted to rotate the image. Same thing has to happen here. To rotate an image, you actually have to rotate the canvas and then do draw image and rotate it back. It's a little weird, but that's how it works. It's a pretty straightforward function. So first thing I did was I actually created a reference to the image. And this is just like an image DOM element right here. So when I set the source, the browser automatically loads it. And this is all running locally. I think in final code, you would need to have something that checks to make sure it's loaded and everything like that before you try to draw it. But this is the command that's actually doing the drawing. It's really simple. It takes the image source and then puts the position on the canvas where you want to draw it. And here's the result. All right. Moving our guy around the screen. White mage. Don't sue me, Square Enix, please. Thank you. OK, next, let's add some bullets to the game. So a bullet is basically another element similar to your avatar and similar to an enemy on the screen. It has a really short lifespan usually, and it would collide with other elements on the screen to deal damage to them. So really, the difference between an enemy that runs towards the character and a bullet that flies toward the character are not that different as far as how you program it. And they usually originate from another element on the screen, like an enemy or your avatar. And for this, I also would suggest doing something like a bullet manager that would track all the different bullets as they're flying through the sky and update them and do the draw function for those, and also to remove the dead bullets once they've hit something or gone off the screen. So let's look at that real quick. So first I added another key thing here for fire. This is going to use the shift key. And also I'm checking, I'll go back over can fire in a minute, but I'm using the avatar in this example as my bullet manager rather than setting up a separate class for that. I'll show you the bullet real quick. Here we go. So the bullet, again, is just, it's basically just another element. It has an x and y position. It has, this one I'm giving it a little bit of physics. It's got a velocity and an acceleration. So it kind of has the appearance that it's launching from your character off to the right like a rocket. And then, yeah, we're just doing the same image and draw functions there. And so like I said, this is the avatar class. Inside of avatar, I'm managing how that bullet, like when that bullet can be fired and when you spawn it, like what happens when you spawn it, what happens when you kill that bullet. So this basically says if there's a bullet already, you can't fire another one. When you spawn it, it uses the middle point of the avatar's image as its spawning point. And I believe up here, yeah, over here, we're doing the, oh, grandma's calling. Okay, so over here, we're doing the code to accelerate the bullet and to kill the bullet when it goes off the screen to the right. So let's just take a look at it. So pretty straightforward. So now we need something to shoot, obviously. We're going to build some enemies. So enemies, again, are just another type of element. These guys are controlled. Their main kind of characteristic is that they're controlled by the computer. And I guess this could be any kind of like character in the game that's not controlled by the human. Usually, you know, like we might make them collidable with the player to deal damage to them. They could be as simple, just a thing that moves back and forth, or something that has loads of different behaviors based on its state, you know, something that could be patrolling or sleeping or talking to its friends around the campfire or something like that. So for this case, we're just going to use something really simple. It's a guy that runs at the player. It's got 4 frames of animation. And actually, we should talk about that too. Sprite Sheets. So Sprite Sheets, if you're familiar with, who does Sprite Sheets with CSS here? Like, okay, yeah, so it's kind of the same concept. You're baking a load of different images into one file, and then you're drawing only a piece of that larger image. And doing that over time creates this animation effect. So if you were to go 1, 2, 3, 4, 5 in rapid succession through this, you would see the entire animation of this guy pulling the ball out of his mouth. And you use the same effect, or the same kind of technique for doing things like background tiles. And really, you could put all of your assets kind of into one file. One of the reasons you do that is that it's faster when you're trying to load that into your GPU. At least another, I'm not sure exactly how that works in JavaScript, but I know other programming languages and systems, loading an image onto the GPU is very cost intensive. So you would want to minimize the number of times you have to do that. Yeah, so anyway, let's just take a look at it. So this is definitely something that would be a lot easier if you had a library. I'm doing this all manually just because I want to talk about how it works. But I'm setting the frame rate for this animation. I'm setting the height and width of the frame that we're going to show. I'm actually going to scale it up a little bit, and it actually needs to track the time so that to make sure that your animation is in sync with when it appears on the screen. So you don't want to have all your guys like running the exact in sync with each other. It would look weird. At least I didn't. So all of this stuff, this is going to get the current animation frame that you're on. Basically, it takes the frame rate and the time that's elapsed since the last frame and kind of figures out where you should be in the animation sequence. And this takes that current frame and turns it into a position where you're going to draw your box, where you're going to draw into the canvas from. And I drew out this is obviously a really dense call right here. So I drew out all the different parameters. We're basically setting the source image, or sending it the source image. These 4 parameters are kind of like the rectangle where your frame is going to be. And then the other 4 are the rectangle in the canvas where you're actually going to draw, so the x, y, width, and height of that. So let's take a look. So we now have bullets and enemies. Oh, by the way, I added a little bit of a, the reason they're bobbing up and down is I actually added like a sine wave function. So it takes the time that's elapsed and runs that through a sine function to get that wavy pattern, which is pretty cool. Not worth, I don't want to look into it right now in too much more detail, but okay, so let's add some collisions so that these bullets are actually doing something and these enemies are actually threatening. So there are a million ways to do collision detection, collision culling, and this is like one of those things that people spend, you know, that probably are, if you go to a video game company, there are probably people that just specialize in doing this sort of thing because it's complicated even in like sophisticated game engines and things like that. We're doing the most simple kind you can possibly do, which is two rectangles trying to decide whether they're overlapping each other. Again, you could do this with like round shapes, you can do it with points, you can do lines, and all kinds of things. We're just going to do rectangle versus rectangle. And the way you're doing that is basically taking the XY position of that rectangle and the width and height and seeing if those numbers overlap with the numbers of the other rectangles, X, Y, width, and height. So for example, if X plus W is greater than this one's X, and Y plus H is greater than this one's Y, then you know that they're colliding with each other. If that wasn't clear, I would recommend taking a little time and like looking through the code for this, because it can be, you know, it's several functions that actually, or several comparisons that have to happen to tell whether something collides. But yeah, so what I like to do generally is to do a detect collision function, and then actually resolve the collisions as sort of a separate step. So in this one, I'm going through all of the different enemies and checking them against the avatar's position. And then I'm doing all the different, then I'm doing all the enemies and checking them against the bullet's position. Because I want to have two different outcomes of this, and those are resolve enemy hit avatar and resolve bullet hit enemy. And so these are the functions that call when that happens. So again, there's like all kinds of ways to optimize this. You might want to, you know, only check things that are close to the enemy. If you can figure that out, you know, store some of your process, like kind of, so you don't have to do every single enemy every single time. You could only check collisions every second frame, for example, all different things. Because you can see how it would add up a lot once you have all these different elements on the screen. Like if you had 100 bullets, that's 100 bullets you have to check against everything else on the screen. Okay, so collisions. And this, incidentally, is where the game starts to feel a little bit like a game. So we actually have the character getting knocked back a little bit when he gets hit, and the bullets are killing the bad guys. Next, text. I added a little text in the next step. I'm not going to go over this too much. It's another canvas command to fill text. You set the font and style, and then fill it with a certain color. This is a little more interesting, the scrolling background that I've added. So I basically took this star field, which is a repeating PNG, and I'm duplicating it out to the right and to the bottom until I reach the edge of the screen. And then I'm scrolling it, doing a similar technique as the sprite animations. So this background has kind of an offset number, and every update loop, it's moving it a little bit to the left, and we're drawing a different section of that. So the result is this fluid background that fills the entire screen. I'm just going to jump straight to the demo of that. So there's the star field, and you can see the point readout in the top right. So you could call this a game now, I guess, except you can't really die. So next is sound. So Joe obviously talked a ton about sound, and this is nowhere near on that level. I'm just using the audio DOM element and setting the value straight, like loading it up, playing it once. I'm not worrying about channels or worrying about stopping those sounds when they're done or anything like that. But let's see, I'll show you that one real quick. So here's the code that actually loads up those sound effects. I'm doing them here as a global object because I didn't want to have to deal with like having didn't make sense for like an enemy to have a hit sound or something like that, or a bullet to have a fire sound, because I don't want to have to load those sounds every time. I just want to reference them once and play them. So here's how we do that. Just sfx.avatarHit.play. And the demos get really annoying starting right here. Okay. So game states. This is kind of an additional layer on top of what we've done so far. So all kinds of things can have a state, and so there's nothing special about games having states. This is if you know your design patterns, this is what would be called the state pattern, and it's a way to model like a finite state machine. Can I get an applause if anybody got that? All right, yes. Okay, cool. So basically, I'm taking all of the. This is a great way to model like different modes of your game. So if you had like a start screen, your game, your settings menu, maybe a pause state, or maybe like a conversation mode or something like that. This is a great way to model all of that and kind of group all those assets together. It's sort of like it gives you one entry point for your update call and your draw call, so that you're not sending it out to all different, like all over the universe, like trying to update and draw everything and find out whether something's actually on the screen or active or not. Just set the different game state and you go with it. Also makes doing transitions between states a little easier and doing memory management, because like you could just close out, you just set a state to null, and if nothing else is linked to those objects, you can like clear them out of memory all in one go. So I'll show you what I'm talking about a little bit here. So I've edited our game a little bit. There's actually a lot of refactoring to make this work, but we now have a current state property of the game, and then I have these two little placeholders for the intro and gameplay state. The reason that they're null here is I don't want them to take up memory until I'm actually using them. But here's where you actually are using them. So this is calling currentState.update and currentState.draw rather than just calling it those functions on the game itself. And you have the gameplay state is basically everything that we've done up to this point has been wrapped up into that and put aside. And I'll show you the intro state, which is this. This is new stuff. So I basically have a title card here, and this has its own update and its own draw. So the draw is real simple. It's just drawing the title card. The update is just going to wait for any keystroke to happen. So every update, it's checking to see get pressed keys is greater than or equal to 1. And when that happens, it's going to call game.startGame. And also, it's nice when all of your states actually have a reference back to the object that owns them. So you can do useful things like starting the game up and changing states. Start game clears the canvas and then instantiates a gameplay state and sets it as the current state. So from here on out, when you call that update call, it's going straight to gameplay state instead of intro state. I'll show you how this looks. So this is the intro state. You can get out of this by hitting escape. That takes you back to the intro state. Last step, this is no real in particular features that we're adding. I just added a bunch of like miscellaneous stuff here. I added a fade in to the intro screen. I added kind of just an effect to the background image. I added a particle generator behind your avatar, so now it has like little sparkles that follow them. And I added a counter for hit points, and now you can actually lose by getting hit too many times. This is kind of our final version of the game. So that you saw that animation comes in. that's really every frame is just like setting a new opacity before it draws the title card, which gives it that effect. So yeah, every frame we're adding a little bit of opacity and drawing it. You can see the little stars in the background. We actually have hit points now. You can die. Yeah. Thanks. So that's really it. Go make something. And yeah, if you have any questions about what you saw, let me know. I actually have a bunch of links. All the source code for this is up on GitHub. I put some links to some different canvas manipulation libraries up there. Physics libraries, Box2D and Coffee Physics are both awesome. Keymaster is that key control thing. Commonwealth is a library I wrote for doing state machines that's a lot more robust than what I showed there. And it's kind of brand new. I'm like looking for feedback if anybody wants to take a look. And that's it. Are there any questions?
Yeah. Have you found any points of Box2D?
Can you say that a little louder, please?
Yeah. Have you found any Box2D ports that still support?
Have I found any Box2D ports? Yeah. So, well, there's Box2D is ported to all kinds of. Well, actually, I mean, I honestly haven't really used it much. I looked at the Box2D JS example that's out there, and it was working for me in Chrome, but I haven't tried it like, in a cross-browser kind of way or anything like that. Anything else?
Is there any reason, well, after incorporating the particle accelerator, that nice little star you put,
Yeah.
do you think about using that maybe like the enemies or anything?
So the question was, after incorporating that particle accelerator, the particle generator, have I thought about time travel? No. Have I thought about adding that to the? Yeah. So basically, the question was about using that sort of particle generator, particle emitter, to do more effects on enemies and other game elements. And yeah, absolutely. If this was a game I wanted to produce for real, I think I would make liberal use of particle generators. And a lot of games you look at actually have tons of it going on, especially modern games. There's tons of particles going on. Anything that's like, you might see like flame, or you might see like, jet dust coming out of the back of a rocket. All that is just particle generators. And to give just a quick description of what that means, it's usually it's something similar to like the enemy manager, where it's spawning these tiny objects on the screen, and usually doing it in a kind of a random way so it looks kind of more natural or organic. But yeah, it's just like spawning tons of little items that fizzle out and die after a second or two. Anything else?
All right, give it up for Mims.
Thank you.